Immunity is defined as a condition in humans that permits innate and acquired resistance to disease. Our immune system has two main defenses. These are called innate and adaptive immunity.
Our immune system relies on receptors that we were born with for the pathogens that we have encoded in our genomes. Innate immunity refers to non-specific defense mechanisms. These mechanisms come into play immediately or within hours of the antigen's appearance. An antigen is a substance foreign to the body. The skin is one of the body's largest innate mechanisms. It is a physical barrier of keratinized cells that are packed closely together. Other secretions such as mucus, sweat, tears, and saliva also protect against infections. Another way our body fights against infections is with the process of phagocytosis, which is when cells take in and break down foreign bodies using powerful digestive enzymes. Physical barriers such as skin, mucus, sweat, tears, and saliva, and excretory processes such as phagocytosis are all key examples of innate immunity.
The innate immune response is activated by the chemical properties of an invading antigen. Innate immunity consists of external barriers formed by the skin and mucous membranes, plus a set of internal cellular and chemical defenses that combat infectious agents that breach the external barriers. Some key players in these internal defenses are macrophages and other phagocytic cells, which ingest and destroy pathogens. Macrophages act by recognizing and engulfing dangerous cells with the proteins on the outside of their own cell membranes, in effect eating them. They digest the antigens with special enzymes and then get rid of the cellular debris. They hold onto a tiny piece of the antigen with their peripheral proteins so that other more specific cells can then detect and destroy the antigen more easily.
Adaptive immunity refers to antigen-specific immune responses. Adaptive immunity is more complex than innate immunity because it is much more specific and specialized. Before this process can continue, an antigen has to be recognized. Once the antigen is recognized, the adaptive cells send out a team of immune cells to attack and kill the antigen. Once the foreign body has been killed, adaptive immunity creates a memory for the infection so that the next time it enters the body, it will be more efficient in responding to that foreign body.
Adaptive defenses are highly specific. They can distinguish one antigen from another even if they only differ slightly. For example, this mechanism can differentiate between a body that causes the flu and a body that causes the common cold. This recognition is achieved by white blood cells called lymphocytes, which produce two main types of immune responses. The two types of responses are humoral and cell-mediated.
In the humoral response, cells derived from B lymphocytes secrete defensive proteins called antibodies that bind to microbes and mark them for elimination. B lymphocytes are present in the humors of the body, meaning the blood, lymph, and interstitial fluid. These lymphocytes are able to send the shape of an antigen and then produce antibodies tailored to the shape of its surface proteins. They also produce memory B cells that create immunity for the rest of our lives by storing information about the structure of dangerous foreign bodies.
In the cell-mediated response, cytotoxic lymphocytes directly destroy infected body cells, cancer cells, or foreign tissues. These are called T lymphocytes, or killer T cells. They are made in the thymus gland and they dock next to and kill our own body cells, including cancer cells, if they are determined to be dangerous by its surface proteins. Both the humoral and the cell-mediated response work with the aid of helper T cells, which send signals for more macrophages to kill foreign bodies already present in the body in the humoral response and initiate killer T cells in the cell-mediated response.
Innate and adaptive immunity work together to fight off and control infections. Innate immunity is not specific to a particular pathogen. It includes physical barriers such as skin and mucus, as well as smaller phagocytic cells such as macrophages that ingest and destroy dangerous pathogens. Adaptive immunity is specific. Adaptive immunity targets each particular pathogen that gains entry into the body using specialized cells. B lymphocytes make specific antibodies in a humoral response, and killer T cells destroy infected cells throughout our bodies in a cell-mediated response. Without all of these complex and layered types of immunity, the body wouldn't be nearly as protected from the dangers of the outside world.